I've got two tables of toys here. I want to find all the toys that are the same in both tables. I could do this using a join, but there is another way. Set operators. Set operators allow you to find all the rows from both tables with union, just those that exist in both tables with intersect, or those that are in one table but not the other with minus. To use them, all you have to do is query the tables and stick the relevant operator between them. But to do this, the tables must be the same shape. That is, return the same number of columns with the same data types in each position. If they're different, you'll get an error. You can overcome this by selecting the columns that are present in both. Union is likely to be the operator you'll use the most. You use this to combine tables with similar data together. For example, say you've got a table of teddies and a table of bricks, and you want to combine them into one toys table. To do this, just select the appropriate columns from each and stick union between the two queries. Do this and you'll get one row for each unique toy in your results. All your kind of duplicate bricks are discarded. So why is this? And how can you avoid it? Well, union adds a distinct operator to the results. This squashes out duplicates. To see all the rows, you need to add the all keyword after union. So you may need to do this to get the answer you want. But even if you're combining tables where you're sure there's no duplicates, it's still worth using the all variant. This is because the distinct operation gives your query more work to do. If your tables are huge, this can really slow your SQL down. Another common reason for using set operators is to find all the rows from one table that aren't in another. For example, say I want to find all the bricks that are in this table, but don't exist in the other one. You could do this with not exists, joining all the columns from the first table to the second in the subquery. But this is tedious if the tables have more than a couple of columns. And null gets in the way again. If any of the columns could be null, you need to ensure you're handling this correctly. Minus simplifies all of this. All you need to do is query both tables and stick minus between them. This is one of the rare cases where null values are considered equal. So the database will handle these correctly without any extra effort from you. Like union, minus removes duplicates. So if you need to see these, you've got to go with not exists. Combining union and minus leads to a classic use case, checking if two tables have exactly the same rows. Let's say I'm splitting up the bricks between my daughters, and to help avoid fights, I want to ensure that the two tables here have exactly the same bricks on them. To do this, we can first check which bricks exist on this table but not this one, and then do the opposite, find the ones on here that don't exist here. Finally, we can combine the results with union to see all the differences. With set operators, this is simple. Minus each table from the other and union the results. But run this and all we get is the bricks in the second table, not in the first. What's going on? In Oracle Database, the set operators all have the same priority, so the query finds all the rows in the first table, not in the second, then it adds back in the rows from the second, before finally removing the rows from the first, which is the same as just minusing the first from the second. You fix this the same way as forcing order of precedence in any mathematical operation. Place brackets around the two minus subqueries. This forces the database to process these first, then combine the results. While this is the classic way to compare tables, you have to read all the rows from both tables twice. Something you want to avoid, particularly if your tables are massive. It's better if you can read the rows from each table just once. To see if we can do this, let's revisit the requirements. We want to see if we have the same bricks in both tables. So, after we combine them, we should have 2 copies of each row in the table. If there's any that appear just once, then we have a mismatch. We can do this by combining the tables with union all, then checking we have 2 copies of each brick, a classic group by operation. And with the having clause, we can filter out the rows we have 2 copies of, so we see just the mismatches. Note, this assumes that each table has no duplicates. If you have two copies of a brick in this table, which don't appear in this one, you'll still get a count of 2 and filter them out of your results incorrectly. What you need to do instead is count how many bricks there are of each type first, then include this in your comparison. You can do this by adding 2 extra columns to each table in your union. For the top table, the first returns 1 and the second 0. And you do the opposite for the bottom table. Summing these up in your outer query will tell you how many bricks you have of each type from each table. So you can find the mismatches by comparing these in the having clause. As a bonus, you can also see which table has the extra rows. Do this by comparing the sums in the select and returning the name of the table which has more. So, we've covered minus and union. Now, you may be thinking to yourself, if minus is similar to not exists, surely intersect is similar to plain old exists. If so, congratulations! Intersect works the same way as an exists with a distinct. So you get all the rows that exist in both tables. You may find great uses for this, but it's rare I've had to use it in real code. So that was a quick overview of set operators. They're a handy way to compare tables, particularly if you have a lot of nulls to deal with. But they have other uses too, particularly union, which we'll use in our next topic, creating SQL trees. Thanks for watching. Have you used set operators? Let us know in the comments. And remember to subscribe for future updates.